Good day to you once more again. In this class today, we want to look at how to write the ionic equation or how to balance the ionic equation for redox reaction. Take note, we are still on oxidation and reduction, but we want to look at how this is the kind of question that normally comes out in exam very well. Follow the step you are going to take now. You will understand the question very well. It's very simple. So let's go now. We have a question here. The question says that we have to write the balanced ionic equation for redox reaction between acidified tetra manganate 7 and ion 2 tetrasulfate 6. Ion 2 tetrasulfate 6. What is the first thing you are going to do there? The first step you are going to take there is let those ions lead to atom or atoms to ion, whichever way. Let them lead to the particular, if they are going to lead to a particular ion, let's show the way they are going to lead to it. That's the first step you are going to take there. Now, for the ion 2, for the manganate, tetraoxomanganate 7, that is MnO4 minus. Now, this one will lead to, that's step 1. This one will lead to Mn2 plus. Mn2 plus. Then the so-called ion 2 tetramanganate 7, ion 2 tetrasulfate 6. That one is only the ion there that we are interested in showing for you. So we have Fe2 plus, this ion 2. That one will lead to, it's into Fe3 plus. The ion 2 will increase to ion 3 in that reaction because the reaction is in an acidic medium. And the tetraoxomanganate 7 ion, the manganese here will lead to 2 plus. What is the oxidation number? That's the next thing you need to note now. The oxidation number of this manganese at the reactant here and compared to that one at the product. That is where you determine where the oxidation is and where is reduction side. Now, oxidation number of the manganese here is plus 7. Why oxidation number of the manganese here is plus 2? What is that? Is that reduction or oxidation? Yes. You can see that that is what? The oxidation number has been reduced. And what is oxidation? Oxidation is what? Loss of electron, which is what? Increase in oxidation number. But this one, oxidation number is reduced at the product side. So this is what? Reduction. Reduction. Now, for this, Fe2 plus. So the oxidation number of this ion here is 2. Oxidation number of ion here is 3. So this is what? The oxidation number has increased. What is oxidation? According to loss and gain of electron. Oxidation is loss of electron, which leads to what? Increase in oxidation number. Oxidation number has increased. So this one is oxidation process. This is oxidation, where it takes place, and that's where the reduction process takes place always. All of them are occurring in the aqueous medium. Take note of that. Now, we are going to now take the step 2 now. We take the reduction of reaction, and because it is in acidic medium, we are going to add hydrogen and water to hydrogen ion to the reactant side, which is going to lead to water. So reduction of reaction, reduction, that's step 2 of reaction. We have MnO4 minus plus hydrogen ion will lead to Mn2 plus water. So let's look at it. Let's balance the atoms now at either side now. How do we balance that now? So let's look at it. We're having one magnesium here, 4 oxygen here, 1 here. So what if I put 4 here? So we're having 4 oxygen here, 4 oxygen here. Fine. 8 hydrogen here, 1 hydrogen here. So I put 8 here. I have been able to balance the equation. So what next I will do now is what? Is to balance the charge. Balance charge. The first thing I do is what? I balance the equation. The next step is what? Is going to balance the charges from the reactant side and that of the product side. Take note that when you are trying to do for the oxidation half reaction as well, that is the thing you are going to do there as well too. It's very easy step to take in getting this. Now, balancing the charge, you're having minus 1 here, minus 1. This one is what? 8 times 1, that's what? Plus 8, that's what? Minus 7. Which leads to what? What is this one here? Plus 2. This one is what? Minus 7. This is 7. Minus 7 plus 2. That's what? This one is what? This one is minus. This one is 7 electron. This one is what? 2 electron. 2 electron here. So which means that this one we need 5 electron here. 5 electron at this particular side here for the acidic medium. 5 electron here. So we are going to now have it to be MnO4 minus plus 8 hydrogen ion plus 5 electron, which leads to what? Mn2 plus 4H2O. Look at it. Plus 4H2O. That is what you do. You stop there. That is for the what? You have been able to handle the reduction of reaction. Now let's look at the oxidation of reaction. Oxidation of reaction. For the oxidation of reaction, we have in what there? Ion 2 leading to the number of atoms is balanced. Number of atoms is balanced there. So we have to do what now? You balance the charge. But the next thing is what? Balance the charge. So we're having, this is 2, this is 3. So what do we balance the charge? We need how many here? Just 1 electron to come in. So we're going to have it to be what? Fe2 plus, with this what? Fe3 plus electron. 1 electron will come to the product side here. That is how you do it for acidic medium. Take note of that. It's very, very important. For the acidic medium, you add hydrogen ion. For the alkaline medium, you add hydroxide ion to lead us to what? Whether we are going to have what we are going to have at the product. Water we have at the product in the two, depending on how the reaction goes. Now, what to do next now is that you are going to look at the electron that we have here. This is 1 electron, and this is what? How many electrons we have here? It's 5 electrons. So you have to do what now? You have to multiply the oxidation of reaction by the number of electrons, which is 5. Multiply 5 by oxidation of reaction. So we are going to have it to be what? 5 Fe2 plus will give us 5 Fe3 plus 5 electron. Because we have to make sure that the electron at both sides is balanced, because the electron at the reactant must be equal to the number of electrons at the product side as well. Then after that, you combine the two equations. Combine oxidation of reaction with reduction of reaction. In that sense, what we have are the reactants for the oxidation or the reduction of reaction. That's what? MnO4 minus, that's it, plus 8 hydrogen ion plus 5 electron. Now what do you have about the reactant of the oxidation reaction? Half reaction, that's all, plus 5 Fe2 plus give us this one leads to, this is the product of this reaction we have here now. This one leads to, what do you have at the product here? Mn2 plus 4H2O plus what do you have at the product of the oxidation of reaction? That's 5 Fe3 plus 5 electron. Now, if you try to collect the like terms, you discover that this 5 electron will cancel each other out. So we have it to be now be what? MnO4 minus plus 8 electron, 8 hydrogen ion, sorry, plus 5 ion 2 will give us Mn2 plus 4 water molecule plus 5 Fe ion 3 Fe3 plus 5 Fe3 plus. That is how you solve a kind of question of this nature. You can see how simple it is. The first step you take there is that you are going to write out the particular equation given to you. You are going to write them out. Then you look at what is going to form at their product. After you'll be able to get what is going to form at their product, for instance, as we have it here now, you can see that manganate, manganate 7 leads to manganese 2 ion. Then ion 2 leads to ion 3. That's the first step you're going to do there. The next step is that you have to identify the reduction half reaction and that of the oxidation half reaction from the knowledge you have about the oxidation and reduction before. After that, what you do is that you have to work on the reduction half reaction by looking at the process of the reduction. You balance the equation first. By this, you have to look at a particular number of hydrogen ion for the acidic medium now. Particular number of hydrogen ion that will be added to the reactant side to have the required number of water at the product side. Then you also balance the charge. Then you put the balance of the charge in the equation there. The same thing you do for the oxidation half reaction. After you have done that, you look at the two charges. You must make sure that the charges at the reactant is equal to the charge you have at the product side as well. After that, you cancel the charges out. Then you write the remaining equation. Everything at the reactant of the reduction half reaction, you add it to everything at the reactant side of the oxidation half reaction, which will lead to the product of what you have at the reduction half reaction and that of the oxidation half reaction. So I hope you have been able to understand the way they have been able to simplify the solving of this kind of a question. Please, we implore you to stay tuned to our channel to enjoy more of our class. Thanks and God bless.